In this example, we're going to find the domain and range of a function in real-world context. This particular example is going to have us building a linear function, and then we're going to determine the appropriate domain and range based off of the context given. So this is the scenario. Since a full tank of gas was purchased, Susie has driven 60 miles and there are 16 gallons left in the tank. After driving 150 miles since filling up, there are 10 gallons left. Assuming the car uses gas at a constant rate, find a function to model the amount of gas in the tank in gallons. Let the independent variable be the number of miles driven since the full tank of gas was purchased. Okay, so it tells us what the input variable is going to be. Okay, so the independent variable, that's what the input is going to be into the function. So when it says let the independent variable be the number of miles driven since a full tank of gas was purchased, I'm going to take note of that right off the bat, and I'm going to say x, my input variable, is the number of miles driven. Okay, and it's saying that the car uses gas at a constant rate, so that's what tells me it's going to be a linear function. And so let's read this again. It says, since a full tank of gas was purchased, Susie has driven 60 miles and there are 16 gallons left in the tank. After driving another 150 miles since filling up, there are 10 gallons left. Okay, so if x is the number of miles driven, that's the input variable, that's the x value. The problem is giving us information about a couple of points, right? At the 60-mile mark, I'm letting that 60 be the x value because that's the number of miles driven. There are 16 gallons left in the tank, right? The gallons of gas is the output, so it's the y value. And then it says at 150 miles, there are 10 gallons left, right? So I'm writing these points as I'm talking. So the point 60, 16 and the point 150, 10 are both points on this function, right? Okay. So if it's a linear function, because it's using gas at a constant rate, then I'm thinking about the form y equals mx plus b, right? And so I know if it's a linear function, I need to find the slope first, right? Okay, so the slope is the difference in y divided by the difference in x, right? So if I have 10 minus 16 on the top, right, that's the difference in y, divided by 150 minus 60 on the bottom, right? So difference in y divided by difference in x. And so what will that be? 10 minus 16 is negative 6. And 150 minus 60 is 90. Okay. Let's see, does that reduce? 6 goes into 90 15 times. Yeah. Okay, so our slope is negative 1 over 15. It makes sense that the slope is negative, right? Because the number of gallons of gas is decreasing as you drive, right? Okay, so now that I have the slope, I know this much, right? Y is equal to negative 1 over 15 x plus b. Okay, now to find b, the y-intercept, I'm going to use one of the points that we were given. I'm going to use 60, 16. It doesn't matter which one you use. So the output value, the y value is 16, and the input value is 60 in our case. Like I said, even if you use the other point, this will work. So I end up with 16 equal to negative 4 plus b. All right. So now add 4 to both sides. 16 plus 4 is equal to negative 4 plus 4 plus b. 16 and 4 is 20. So 20 is equal to b. Okay, now we found the slope and we found the y-intercept. So then from there, state what the function is going to be, right? And this is the number of gallons in the gas tank, so I'm going to call it g. It didn't tell me what I needed to call it, but I'm going to call it g of x equal to negative 1 over 15x plus 20. So this function, g of x, gives the number of gallons in the tank as a function of the number of miles driven. Yeah? So our next task is to find the domain of the function in this context. If you just look at the function itself, g of x is equal to negative 1 over 15x plus 20. You would say, well, it's linear and there's nothing limiting about it, right? Every x value we put in there would get an output value in return. Now the question is, can we put any x value in there? Like if we drive 600 miles, is there going to be any gas left in the tank? Will we even be able to drive that far? So that's the kind of question that comes into play when we're asking ourselves, well, what's the context of this? Okay, so my question would be, I'm just think about this graphically for a moment. So 4, 8, 12, 16, 20. Okay, I'm up here at 20. I know that's the y-intercept, right? Okay, and then down here, I better label my axes here, x and y here. Now the question for me, okay, we know the slope is negative, so it's going to have it's going to be a decreasing line, but where does this hit the x-axis, right? Because that gives us, x represents the number of miles driven, and we want to know how many miles we can drive on that tank of gas, right? Because once we've hit that, we can't drive any further. So how would I find that? I'm really interested to know what's the x-intercept of this, right? And to find an x-intercept, I have to let y be 0, so I have to let the output be 0. That being the case, I'm going to have negative 1 over 15x plus 20 equal to 0, right? The output is 0. So I'm going to subtract 20 from both sides. We have negative 1 over 15x plus 20 minus 20 equal to 0 minus 20. Negative 1 over 15x equal to negative 20. Then I need to multiply both sides by negative 15. All right, so we're left with x on the left-hand side, and on the right, what's 20 times 15? Well, 2 times 5 is 30, right? So I'm going to have 300. Okay, so that means the x-intercept is out here at 300. So doing a very rough freehand sketch of this, but that's essentially the function, the piece of the function that we know something about, right? The number of miles that we can drive on a tank of gas. The range gives us the gallons of gas in the tank, right? So the x-axis here is the miles, and the y-axis is the gallons in the tank. Okay, so if I were to just look at this piece that I graphed, right, and it makes sense that I'm not going to have, if this extended to the left of the y-axis, I'd be driving a negative number of miles, which doesn't make any sense. And then if I were to extend it past the x-intercept, I would be driving when there's no gas in the tank, which also doesn't make sense. So we want just this piece of it. And the domain would be 0 to 300, right? Those are the number of miles that you can drive on the tank of gas. All right, and the range of this function in context would be 0 to 20, right? And 20 is the number of gallons. So essentially, we're saying we've got a 20-gallon tank, right? And we can drive 300 miles on that tank of gas.